because
All right, we're live.
well, no, I meant when we start recording, I'll turn my AC off because what I've realized is people can't generally pick it up, but Chad can sure pick it up. And I like Chad and I also like being cool, so I will compromise.
That's great. But no, for sure, Chad gives me a hard time. Can you move your computer any further away from the way you record? So,
All my fish tanks are turned off right now.
oh, that's really thoughtful. Um, man, what's happening?
Life, the universe, and everything continues, and
It,
we
but
are in.
it's Happy Towel Day.
I know, I had my towel. There it is. I have my towel.
Speaking of sci-fi holidays that I can get behind.
Yes.
All right, time for me to mispronounce everybody's names as they were joking about in the chat beforehand. So, Astro B, Astro YYZ. Is that because
Astro Wise.
yeah, but it's YYZ, which is a airport in Canada, which makes me think that's where they're located. But if it's Astro Wise, then that's cool too. Chris Adams, Deepak Singh, Enoch, Galaxia, Graham W, Guido Bibra, Harry M, Holly Meyer, Helg Bjorkog, James Aberson, John Suffield, Quad Libet, Quod Ilbet. So
I now really want to know if it's Astro YYZ or
I
Astro
hope they'll say in the
Wise.
chat. Larry Beckham, Linda Sadek, Mr. Tom Harbin, Nancy Graziano, Oberon Knights here, Paul Smith, Peter Quinn, Peter Wyeth, Rick Schwartz, Side MT, Steve Chisnell, Tony Reggett, Uncle Bill Druin, and Zapfan. Hey, everybody, welcome. And then people
Hello.
were also mentioning, I didn't avoid you. Hold on. I just got to get this, say this right here. Brooke Mulugeta. There you go.
There are reasons you do this instead of me.
Yeah. So there we go. Hold on. So he says, yeah, see, Astro YYZ says YYZ because I'm in Toronto. That is the airport code for Toronto.
But Astro Wise is
It's
so
it is
cool. Can I
cool and
call
it
you Astro Wise?
has like a double meaning. So,
It's true. It's true.
all right. And Richard, I'm gonna say hello. Daniel McCool, hello. All right, so if you're wondering what it is that you have stumbled into, this is going to be a episode of Astronomy Cast, episode 493. We're going to do an update about Mars.
It's true. Any announcements before we get started?
Steve Chisel says it should be Yankee Yankee Zulu. Sounds good. I don't know. No,
Do
it's no way. I mean, probably for sure if you're gonna like pronounce each of the individual letters. But in Canada, right? My nearby airport is YQQ. The
yeah.
one in Vancouver is YVR. Uh, YTO. And
So
there's yeah.
so in Canada when you're doing the whole Echo Tango Foxtrot thing,
hmm
do you use Yankee?
I believe so. Yeah.
Alrighty then.
Yeah. It's, I don't know. But we don't say YYZ because that would just be crazy. All right. Let's. So we're gonna record the episode. You're going to hang out with us and feel free to chat, and then we will stick around for another half hour or so, and we'll answer your questions about space and astronomy. All right. Are you ready there?
I think so. I had one quick thing I wanted to say, and that is for those of you who don't know this, and I'm searching my desk real fast. I have been painting planets in all
Oh,
different
hold on. Let me just
sizes.
change the. There we go. Can you go back a little bit? It's sort of out of focus. There you go. Very
So I've been
cool.
painting planets.
Yep.
This is an icy moon that
Nice.
has some little tiny volcanoes on it. And these are for sale on Etsy in the 739 Studios shop. And if you buy planets, I'm actually like using the funds to like pay people and support projects and things like that. So if you like planets and you want one that I painted,
That's cool.
739 Studios.
Right on. I don't understand how you have the time to do this, but
I just spend Saturday afternoons painting on the internet. It's literally what I do. So
that's
if you
cool.
tune into my Twitch channel on Saturday afternoons, I will be here painting things with more or less success, depending on what I'm trying to
I
do.
don't think I can sell anything from my gardening that I do on Saturday afternoons.
That's probably true.
Speaking of, I really got to mow. All right, let us begin this Astronomy
Okay,
Cast. Are you ready?
I am. I'm pressing record.
I have also pressed record. Hello, Chad.
Hello, Chad. I turned my AC off just for you. So I
Oh,
shall be sweltering and hot because I respect your audio editing.
wow. There we go. All right. Astronomy Cast, episode 493, updates about Mars. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, Dr. Pamela, the Director of Technology, Citizen Science at the Astronomical Society of the Pacific, and the Director of Cosmic Quest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Great. I don't know if I mentioned this last week, but I'm going to mention this again, which is that we have a book of the Universe Today's complete guide to viewing the cosmos, and we have a cover by Robert Gendler, and we have a link on Amazon if you want to pre-order the book, which I
And
hope
I owe
you
you a
do.
forward.
And it's going to have a forward from Dr. Pamela Gay, so at some point that forward will exist. Maybe that's why I'm just announcing this, is that
I just wrote a
there
note.
we go, that you remember to write your forward. But the publishing date is in October 23rd, I believe. So I'm really excited, and we're still trying to sort of find space for more amateur astrophotos to put into the book, nagging all of the photographers that we know. So that's the hope, is it's going to be tons and tons of pictures that nobody's ever seen. So anyway, I know I probably mentioned this last week. I'll mention this a few more times. Pretty excited, but definitely check it out. All right. So if there's one place we've learned more about in the last 10 years, it's Mars. Thanks to all those rovers, orbiters, landers, which are flying overhead, crawling around the surface, and digging into that rich Martian regolith. What have we learned about Elon Musk's future home? I love that you don't know what my intros are going to be, and so you have to just kind of, you get as surprised as the audience. Um, this is great. So another episode that we can definitely say new things have happened. Another place in the universe that we know a lot more about than we did 10 years ago. Although
Eve,
we have brought the listeners along with us as some of these have been discovered, but
and the number of things that we're realizing we don't know more than we knew before, and we may be wrong both then and now, is also kind of intriguing when it comes to Mars.
that's how it works, right? Is that if you're
Yes.
doing science, if you're doing science's job right, for every question that you answer, you ask two new questions, and the to-do list of questions just keeps growing and growing faster than you can stay on top of them. So I think that's all fine. So where do we want to start? I mean, I think there are some big things that we should talk about. Some of the big, like, there's spirit and opportunity, and then there's curiosity, and those have turned up some really big. Let's talk about the story of water, then the history of water, and sort of where we're at now with the discovery of sort of the history of water on the surface of Mars.
And it's not just the rovers. We need to remember ExoMars, Trace Gas Orbiter. We need to remember Maven. Uh, this is a world that is surrounded by spacecraft and crawling with a couple spacecraft. Uh, so all of these spacecraft are working together to try and figure out the history of this world. And because we're kind of desperate to get there, because who wants to stay on the planet Earth? Uh, because we're all kind of desperate to get there, each in their own way, they're kind of studying the history of water as they study the history of the planet. So when we first started this episode, it was before Phoenix. It was
Before we started the
in,
show, before we started
yeah,
Astronomy Cast, yeah.
yeah. Phoenix was something we encountered midway through this show, and we had to do updates with that little rover reaching down, pawing its way across the surface, and revealing water ice that then happily sublimated into oblivion. And I just love that image of it basically reached out and scraped across the surface with its little paw, which was a robot arm, but
Yep.
in my head, it's a paw.
See, I just
And
imagine like one of those, those like kids sit on this kind of like little shovel, and they've got these little,
yes,
you know what I mean? And it's got this sort of
yeah.
little arm that reaches out and sort of digs on the regolith. That's what I imagine, Phoenix looked like.
And this was our first clear, indisputable, this is water right here discovery. And from there, we have simply been debating the details. And the details refuse to clarify themselves. So I think my personal greatest frustration is the are they, aren't they identity of the dark streaks on Mars. Um, do you have a favorite are they, aren't they water
Well, I
story?
mean, but I think that's a great example by us being patient and only sort of covering this now. We've been able to miss the water's been found on Mars. Oh, probably not water. So we sort of passed through the whole cycle. Well, let's explain that just to give people sort of an idea of what those are they, aren't they dark streaks.
They're in a variety of locations on Mars. There are these seasonal dark streaks that appear across the surface of the edges of craters, the edges of hills. And because they're seasonal and because they often appear in repeating places, but not exactly the same every year, it was thought, and this was work done by an undergrad and a grad student that was really quite solid. It was thought that this might indicate there was seasonal melting and flowing of water across the surface. And there was much rejoicing. But because it's Mars, no one let such a discovery stand for very long. So more researchers came along and found other ways to explain the dark streaks as essentially seasonal avalanches. Little tiny ones, not very exciting ones, but it appears that there is not water seeping across the surface, creating these dark streaks if you belong to one camp, and this is water seeping across the surface if you belong to another camp.
But the evidence now is that it is just little landslides on the side of these craters that are sort of they're at the perfect angle that sand would crumble and fall down
Mm-hmm.
the slope. And that's what they're finding is you get this seasonal change, the temperatures change, and it sort of kicks up a little bit of the sand and it falls down into the crater. And that does seem to kind of nicely explain what's happening here, and that it's not some weird elaborate water pouring out the sides of these craters, or maybe there's some kind of liquid carbon dioxide that's rushing out and causing these flows. It really does look like it's just sand.
But there are those remaining in the it is water camp.
Sure.
And this won't be completely sorted out until we can send something to explore the dark streaks.
Right.
But due to the fact that we have not done a good job sterilizing Curiosity or Opportunity, which are our two current rovers on the surface, nor could Opportunity get to one. Um, well, yeah, they're not getting explored anytime soon, so the debate shall continue.
Yes. But one thing that is not debate is that there was water on the surface of Mars a long time ago. That was what we found from Spirit and Opportunity. And Curiosity showed that that water was on the surface for a long time, many
And
in several different ways.
And what's really amazing is looking at all of the different kinds of sediments, the different kinds of soil textures, soil formations that Curiosity is observing on the surface of Mars. It looks like a whole bunch of dried out riverbeds. It has that same baked, dry, cracked mud that anyone who's explored the American Southwest after the monsoons has seen before. And it's amazing to think that Mars had these oceans, and we'd had hints previously. You look at a lot of the craters on Mars and you see what looks like outflow canals, places where water filled up a crater and then broke through the edge and created a gushing stream or rivulet out of the crater. So we'd seen that. And we wanted to believe this was formed by water. But with Mars in situ, it suddenly becomes clear, yes, the only way to get these particular structures is with water.
Yeah, and so they've found multiple lines of evidence at this point. They've found rocks which can only form with the presence of water, the minerals in the
Hematite.
rocks. They've found structures called concretions, which are these little balls that have rolled around, and those can only form through sort of water-based processes.
Yes.
And I don't know if I've mentioned this in the past, but we have concretions in the rivers by my house,
Oh, that's cool.
but they're big. Like these concretions are sort of basketball sized, and so if you find one of them, mostly they're broken, but each one
Uh-huh.
contains a fossil in the middle, and so the concretion formed around some ancient object, a fossil or something. And so you take one of these concretions and you smash it, and you find a fish inside, or you find a an ancient leaf or a fern or something like that. And we have a dinosaur, or actually, it was a plesiosaur here, and it was found because the head was in one of these concretions that had rolled out of the side of the bank. So anyway,
So people just like walk around cracking these
mm-hmm.
open, and now I want to have the rovers on Mars. Like,
Cracking open, well, but they're these little blueberries, these little tiny ones. But here, like I
yeah,
said, you can, and you don't find fully spherical ones anymore. They're almost all cracked open, and so you can kind of, and it's not because people have done it. It's just, the weathering
water.
process of just cracked them all, so you very rarely see them in any kind of form. But yeah, absolutely. The next rover should crack open concretions and find fossils inside. That would be awesome. But so and there have been other lines of evidence for water as well, and it's piling up and piling up, and now they're sort of really getting a sense of when and how long and where and so on. Let's talk about in the back into the mystery area. Let's talk about methane.
So there has been various detections and lack of detections of methane on Mars, where it was thought that we were detecting it. Some of the orbiting spacecraft saw signs that they were detecting it. But as far as I know, the rovers haven't detected methane. And so we don't know where it may be coming from. We don't know if it's geological origins because this is supposed to be a geologically dead world. We don't know if it has biological origins, but this is supposed to be a biologically dead world. So our dead planet is less dead than we thought. And the question is, are the rocks alive or are there critters?
And both are absolutely fascinating
Yes.
possibilities, right? The fact that
Yes.
Mars still has volcanism going on inside of it, and that volcanism is reaching the surface and putting out outgassing, is an absolutely fascinating thing. And people thought that Mars was dead for a long time. All right, that's second to the more interesting possibility that there's life there, that there's bacteria there, and the evidence, is that it's seasonal. The really fascinating idea is that it is seasonal. So the
Yes.
Curiosity rover detected this stuff rising and falling over the course of the seasons.
And that is information I didn't
No, you
have.
didn't know that.
So,
Yeah. But
yeah.
it's not a slam dunk. So around, and the other possibility, as the temperature rises, it could be that the the
Something thaws.
something is thawing and it's releasing this material. And another sort of possibility is that the rover itself is giving off the methane that it's
We have
outgassing.
we have a farty rover.
Yeah, exactly. Yeah. So we need a second rover and so on.
And what we've learned about the volcanoes, one of the most amazing things that I saw was people are now starting to think that Valles Marineris may have formed when the planet cracked open as a result of how much lava outpoured from those three main volcanoes that you can see even from a backyard telescope. And so the debate of was the valley formed with water? Was the valley formed with wind? It turns out, no, it's just the planet cracked
Hmm.
open. And this is something we see on our own planet. We see in Ethiopia the rift valleys that are actively forming. Now the reasons are different, but this idea of a planet cracking open, um, well, now we know it happens more than just here.
One of the other detections that the Curiosity rover made was a very accurate measurement of the radiation falling on the surface of Mars. And that's kind of bad news for people who want to live on Mars.
Yeah, so we've talked about this a lot on the show. One of the biggest issues with trying to get to Mars is all the solar activity that you're going to be exposed to on the way there. Well, now it turns out that just being there could kill you. And so our prediction that when humans do get to Mars, you're going to have to live beneath the surface, well, that's still true. So it's not the world that Elon Musk is going to live on, it's the world Elon Musk is going to live under the surface of.
Right. As long as he and his friends are willing to live in lava tubes or bunkers underground, it should all work out okay. But and I forget the exact numbers, but the Curiosity rover, when it made its journey to Mars, it was equipped with radiation sensors. The RAD experiment, and now that it's on the surface of Mars, it's continuing to measure the radiation, and it's this ongoing galactic cosmic radiation that is streaming in, not to mention the radiation that's coming from the sun, and we really have no way to prevent either of those.
Yeah.
And and a solar flare is even worse, and there's just no protection. There is some protection from the atmosphere on Mars, but apart from that, it's not as good as being here on Earth.
Yeah. So we're kind of out of luck there. We're really looking at something that's kind of the equivalent of like 24 CAT scans per 180 days, which adds up.
Yeah, you don't want that. No. And
No.
so, I mean, this is one of the issues when you think about the astronauts in the future who are going to be asked to go to Mars and explore. They're going to take 9 months to get there. If they want to do, if they want to time their return, they're probably going to have to stay a year on Mars, and they're going to have to take 9 months to come back. Like a journey on to Mars and back is a multi-year commitment, and it is an
Yes.
increased risk of radiation to go through that. So people are going to have to decide if that's the risk that they're going to want to take. Of course, they're going to say yes, but I think they need to at least be informed.
Well, the way I always look at it is this is the perfect last journey for your elder astronaut.
Right? Send the John Glenn's and the right and the Buzz. I'm sure Buzz
Yeah.
Aldrin would go back.
Oh, totally.
Yeah, and John Glenn went back to space when he was after being a
A
senator,
senator.
and yeah, and yeah, I'm sure if we asked Buzz Aldrin, he would totally do it.
And what's kind of interesting is here in the United States, we have regulations on exactly how much radiation you're allowed to encounter within the workplace. And they already have special exemptions for the astronauts. So it may be that we just need to have more special exemptions for whoever goes to Mars, because let's face it, workplace safety is going to have slightly different definitions on the red planet.
Yeah. What else have we learned about Mars?
Well, so one of the interesting things that's just come out in the past week actually is there's different scientists who are trying to understand the formation of various objects in our solar system from Pluto to Mars to Earth. And a paper that came out just yesterday uh, talked about how it looks like Mars is made up with a combination of two different kinds of chondroid asteroids that hit and merged and hit and merged. And so it's possible that Mars was built up during the age of heavy bombardment. There is another paper that then looked at the formation, and this is an older paper. It looked at the formation of Phobos and Deimos, the two moons of Mars. And that paper said that these aren't captured asteroids, which is what we thought when we first talked about Mars. Instead, it's now considered that just like our own moon, Phobos and Deimos were formed when some large object hit Mars, sent a large splash of material into outer space, and it coalesced into these two potatoes in orbit.
That sounds familiar.
Yeah.
Something that
So,
happened to us.
yeah, we just ended up with a sphere instead of a potato.
Yeah. Yeah, well, because more material. We got hit by a bigger object.
Well, we were hit by a Mars sized
Right.
object.
And Mars clearly, probably
Would not have
wasn't.
survived
Yeah.
that. No,
Yeah.
no.
Well, and another fairly interesting piece of research, again, fairly recent, is this idea that Mars is as big as it could have been thanks to Jupiter and Saturn, that their influence in the solar system prevented and scattered any additional material from accreting in and joining the mass of Mars. So thanks to Jupiter, Mars isn't a more habitable planet.
And this all comes down to that terrible period where it's theorized that Jupiter and Saturn were in a 2 to 3 resonance, with Jupiter going around 3 times for every 2 times Saturn went around. And during this terrible resonance, it wasn't that Jupiter was protecting us, it's that Jupiter and Saturn were sending objects in all random directions and destroying things haphazardly as they did this.
What else you got?
I so at the end of the day, I think all that we're getting out of the atmospheric studies is most intriguing. We're starting to really understand the mass loss rates that are going on thanks to MAVEN. ExoMars is continuing this research, helping us realize that without that magnetic field, uh, Mars is continuing and continuing to lose its atmosphere, which is both interesting to study and also terrible when you start thinking about we'd like to terraform it and we probably shouldn't try.
Yeah, I mean the most reasonable strategy that I've heard explained for how you might do this is that you would set up like a shield at the Mars the Mars Sun L1 Lagrange point that would block the solar radiation coming from the sun.
Yeah.
And then what that would do is that would stop the atmosphere from leaving Mars, and you would actually warm up the planet enough that the poles would melt, that you would get a much you get a thickening of the atmosphere. But it's, can you imagine the megastructure? But Jim Green, the head of planetary science at NASA, sort of,
He's actually the new NASA chief scientist.
right, and he pitched that at one of the NASA planetary meetings, and I thought it was great to see that. Even normally, so they're all the folks working at NASA, especially in the sort of the higher ends of the bureaucracy, tend to be a lot more conservative about some of their ideas, and it was great to have him putting out one of these, like, clearly it's like a crazy mega structure to build, but
Yeah.
but if you want to terraform and make Mars a habitable place, that building that alone would take you a lot of the way to getting there. It would prevent the atmosphere loss, make the place a lot better. Let's talk a little bit about what people can expect shortly, because there is a ton of stuff still happening, making its way to Mars right now. We're only just getting started.
Yeah, the thing that has me most excited is the InSight mission, which is a lander currently on its way to the red planet. It has two different primary science components. One is a seismometer that is going to look for tectonic activity and for asteroid impacts that cause Mars to shake. There are two different kinds of waves that move through planets. They're called P waves and S waves. Name doesn't really matter. What matters is one of these will pass happily through liquid, changing a bit as it goes. Travel times differ. The other will bend around a liquid core. So you can get different arrival times from these two different kinds of waves that are both generated at the exact same place. And by mapping out a whole bunch of quakes that are either generated by the internal activity of the world or stuff hitting it externally, this will allow us to once and for all answer the question, is there any liquid core left in Mars? And that's kind of cool. But what is even more interesting and, dare I say, hot is the InSight mission also has a thermal probe that is going to dig itself under the
Mm-hmm.
surface. And I can't remember a planetary conference that I've gone to where there hasn't been at least one scientist speculating about subsurface temperatures and where it would be warm enough to support water of this acidity or that saltiness. And it's only been speculation because we don't know the exact thermal properties of the Mars soil. And with InSight, we're going to finally get direct measurements. Now, it's only measurements in one place. It's going to land, dig, stay put. But it's one measurement, which is still greater than zero.
Mm-hmm.
And one of the tantalizing things that occurred to me when we were talking about the Galileo discoveries of ice plumes is you can actually sense when you fly through different water by how other things suddenly change. And it's possible that if this little probe digs itself down through water, variations in its readings will allow us to detect that. And I don't think that's going to happen, but it's just kind of cool to think about its possibility of happening.
And in sort of together with the InSight lander, NASA sent two adorable CubeSats as well, and we got a great sort of pale blue dot and moon image from those, which was wonderful. But I love this idea, and I've talked about this a few times on different platforms in the last couple of weeks, that there's so much infrastructure built up at Mars now in terms of communication and relaying that you can start sending these small, inexpensive spacecraft all the way to Mars. And so you have these two CubeSats. They would not be able to communicate anything they find back to Earth, but they're going to be testing a whole bunch of sort of micro technologies at Mars, and then use this existing relay network to get that data back to Earth. So there's a real value in infrastructure that's happening at Mars. All right, before we close this up, the big piece of exploration coming soon is going to be the Mars 2020 rover, which is
Yes.
going to be this, not exactly a carbon copy of Curiosity. It's going to have, but it's going to be searching for the Holy Grail. It's going to be looking for life.
And it's not looking for life, it's looking for complex organic materials consistent with life. But yes, and it's going to be picking up and collecting rocks, and theoretically someday we're going to send another spacecraft to gather those rocks from the Mars 2020 and bring them back so that we have a cool distribution of different samples that we can study. Now, along with the Mars 2020 rover, they are now also looking at sending a helicopter to Mars. I think helicopter may be a strong
Yeah.
word. I'm more comfortable saying drone. It's not a quadcopter or anything cool like that, but it is tiny
Yeah.
and it's solar electric. And one of the amazing things to think about how hard this is going to be is helicopters that we have here on Earth are really only capable of flying up to 40,000 feet, whereas the surface atmosphere on Mars is the equivalent of going 100,000 feet up.
Right. The rotors on this is going to turn 3,000 RPM.
Yeah.
And it's got two
Yes.
rotors, and they go in opposite directions, which is cool. It's going to have its own solar panels, so it's going to be able to recharge itself and be completely independent from the rover. And in theory, it's going to fly around and scout out the area around the rover, and then give it give operators back on Earth a whole another set of eyes on where they should be going and what they should be looking at.
And one of the use cases for it that deeply amused me is if there aren't enough gusts of wind, it will be able to use its rotors to clean off the solar panels on Mars 2020. And all of these different things are made possible because of this fleet of aged spacecraft orbiting Mars. The 2001 Mars Odyssey mission is still there. We still have Mars Express. We still have Mars Reconnaissance Orbiter. And all of these satellites,
India's Mom mission,
these
the
these
European
different,
Space Agency. There's so many.
yeah. And so we have Mars Orbiter mission, MOM. We have ExoMars, which is Europe. We have another mission called Maven from the United States. And all of these missions have that capacity to be comms satellites for the rovers crawling around on the surface. So the rover doesn't have to carry all the
Yep.
capabilities to call back to Earth. Instead, they just call up to orbit, and these higher power spacecraft in orbit are what call home.
Yeah, I would love to see more spacecraft, more communications relay satellites at more places in the solar system. Because
Yes.
then you could send these smaller, simpler spacecraft that don't need all that big electronics just to be able to communicate. That's one of, I think, going to be a really exciting progression shortly. All right, well, I think we've wrapped up another episode. Thanks as always, Pamela. We'll see you next week.
See y'all. Bye bye.
Don't go
And
anywhere.
now we save.
What did I say it was? Episode.
I don't know yet.
I think I said it was episode.
We are looking
493.
at, yeah. Oh, apparently I have another project named 483.
493.
That would be why.
Yeah. Thanks, Larry and Gordon.
What did they do?
Oh, just noting the episode number. Steve Chisnell, you were saying that you like the idea of a fixed wing aircraft. They should test both. There was a proposal that came out of NASA about, I'm going to say 5 years ago, and they had a sort of a plan for what a fixed wing aircraft might look like, and it seemed pretty interesting. But it'd be the kind of thing that it would, when it came into the atmosphere, it would release the airplane, and then it would fly for as long as it could,
Yeah.
and then crash. The other part that I really like is this idea of a balloon. So you have a balloon that rises and falls at the depending on the time of the day. And so
Hmm.
during the day, it would warm up, it would heat up, and the balloon would expand. It would lift up, and it would float across the surface, doing science. And then at nighttime, the balloon would descend, and it would sort of flop on the surface of Mars for the night, and then next day it would rise back up again. And I thought that was a great idea as well. So
Yeah.
having some kind of air-based way of exploring Mars is really exciting. And it's the same idea for going to Titan and all these places. Like, just being able to get up into the air lets you see so much.
And if we can figure out Mars, every other world is going to be easier if it has an atmosphere because Mars has such a tenuous atmosphere. Titan, as you've brought up before, either of us could wear wings and
Yeah,
flap around quite
yeah,
happily.
very easy to run a helicopter on Titan.
Oh yeah.
Yeah, and this is of course one of the plans that NASA is considering
Hmm.
against a comet sample return mission. Although to have to choose, I don't like it. So hit us with your questions. I know a bunch popped in. Let's get cracking. Arjun asks, could NASA do a mission using their nuclear engine thing? What kinds of missions could a resource like that allow that are not feasible now? So are you familiar with the kilopower concept that NASA announced?
This isn't the fact that they turned plutonium back on. This is something
No,
else.
this is something else. Yeah. So
No, that one I don't know about.
about 3 weeks ago, NASA announced a project they're working on called Kilopower, and it is going to be a compact fission reactor that would be used for future, say, lunar exploration missions, missions to Mars, things like that. So, let's say you had a compact fission reactor, like the Soviets used. Like the Soviets had, I think, 20
Yes,
plus fission reactors on their spacecraft.
that's a bit terrifying.
Yeah, on the moon, you know, to Venus, places like that. So, if you had a compact fission reactor, would you be able to get some work done with that?
Oh yeah. Yeah. Not a problem. I'm more comfortable with the radiothermal generators like we have on Curiosity. Um, and fission, we have trouble getting it to work in giant power plants on the planet Earth in a long-term consistent way. Um, so I'd rather turn on our radiothermal generators. But that's me. I
Right. No,
I
and,
like
and
my
that has
technology rock solid.
and that has been turned on as well. So both are
Yeah.
going to be happening, but there's only so much energy you can get. You can get a few hundred watts out of an RTG, while you can get
Right.
thousands of watts out of a fission reactor. So,
And the difference is the power from the radiothermal generator comes from the natural decay of the plutonium or polonium rather in the radiothermal generators, and that process generates heat, which turns a generator.
yeah.
With the fission, it's like nuclear power plant, basically.
Steve Chisnell is asking, I hear that the Martian regolith is extremely rich in hexavalent chromium, and hexchrome is one of the most potent carcinogens known to man. Is this a potential threat to a human colony?
I I don't know. I know that there's perchlorates,
Yeah.
which are already sort of like
Poison?
bad. So you just named a new
Yeah.
poison for me.
So for the
Yeah.
perchlorates, the strategy is wash your dirt.
Mm-hmm.
And apparently with, fairly straightforward washing process, you can get the perchlorates out. But I haven't heard about the hexavalent chromium, and if it's like part of the soil, it's going to get taken up by plant matter, and you don't want to ingest that. But I think in general, there's no need overall to use regolith as a substrate for your plants. Like, you can grow plants hydroponically, no problem. And it's here on Earth. We put plants in dirt because it's easy, but
Mm-hmm.
but you can run a perfectly happy hydroponic system and not go anywhere near dirt. So I would assume, especially if they have that kind of stuff in the soil, that that's what they would do.
And it's the paper I'm looking at right now is saying that it's 150 parts per million in airborne dust. So the goal is you don't breathe the air on Mars.
Yeah, yeah.
So
Well, but I mean, so the dust on the moon is this asbestos, sharp, jagged chunks of glass that are going to get in your lungs and give you lung cancer. And it
mhm.
sounds like on Mars, you've got the hexavalent chromium, which you're going to breathe in. It's going to get everywhere. So in both conditions now, it really looks like you're going to have to uh, make sure that the dust on from the planet you're exploring doesn't get anywhere near the inside of your habitat.
And I'm seeing recommendations from the National Research Councils that there's a bunch of different materials, of which this is only one, that have got to be better measured on Mars before we send humans.
Yeah.
Uh, so The one that I find particularly terrifying is carbon disulfide, which is another, and we kill you. Um, Acylic acid, we don't have good information on. So these are
More
things we need to
research
learn.
necessary. Maybe go spend a little more time doing some science before you send BFRs filled with colonists and sort of dump them out onto the surface of Mars.
Yes.
That
Yes.
might make sense. Um, Graham W asks, "Do you think that SpaceX will provide the transport to Mars for astronauts and NASA the habitats?" So
Yes.
how do you think the two are going to play out? You think that's the most likely?
I this is me speaking with my personal opinion. No one has supported this opinion. No one is paying for this opinion. This is me giving an opinion that is my opinion. Um, I think that BFR will probably see completion and commercial launches before the SLS sees completion and commercial launches that aren't already on its docket. I wouldn't be surprised if the BFR just flat out saw launch first. Um,
Well, next year is the
yeah,
plan.
thus the launch
Right.
first. So, given how far in the future you'd have to wait before there's an available launch on the space launch systems, it's gonna be Musk as near as I can tell.
Mm-hmm.
And
What do you think would happen? Like if let's say in the perfect world and there's no delays, next year we see tests of the BFR, 2020 we see orbital tests of the full stack of the BFR.
mhm.
What does that do to the SLS, do you think, at that point? Like,
I
do they just
don't.
cancel it at that point? Or do they keep
So,
building it until it's just utterly ridiculous to keep,
well, I think that may have already happened. Uh, the issue with the space launch systems is we don't want to rely on a single supplier of spacecraft anymore. And the space launch system is being built by old aerospace, Lockheed Boehm consortium of all the well-known players. Then we have Elon Musk and SpaceX. We have Bezos and Blue Origins. Sierra Nevada is out there. And so New Space, which runs a little bit faster and looser and has individuals investing their own money as opposed to NASA being the sole contributor of funds, um, they're able to accomplish things in a very different way. And I have a feeling that we will keep funding space launch systems perhaps longer than it's clearly obvious that we should, because this is old, tried and true companies who've been building our rockets for so long. There's jobs at stake, there's lobbyists in
mm-hmm.
play, and you have this entire machine supporting keeping SLS funded. At the same time, it does start to be a case, if Musk succeeds, of how do we continue to justify this expenditure? Now, the one thing that Musk hasn't done yet is launch humans on any of his rockets. I think once that starts to happen, we're going to start to see interesting debates in Congress. And I don't know what the outcome of that will be.
Yeah, Musk just released some cool pictures of the crewed Dragon spacecraft, which looks really cool. Actually, I put a link, I put a photo of that in my email newsletter, and it's really cool looking.
Yeah.
Yeah, absolutely. I I mean, it's like, I mean, a lot of people, I get this a lot, right? People are like, oh, you should cancel SLS. It's ridiculous that they have, but that they're doing SLS. They should cancel it tomorrow. But if they cancel it tomorrow, and SpaceX reaches unsurmountable technical hurdles in
Mm-hmm.
developing the BFR, then we're back to zero.
Well, and there's
right?
already so many different contracts that are awarded, so many
Oh yeah,
missions that have been
yeah,
allocated. Now, what we did see was with the launch earlier this week of Grace follow-up mission and the suite of Iridium satellites. Those were launches that were scheduled on the Russian Dnepr rockets, and we're no longer flying US payloads on those Russian rockets. And it turned out that by using just a regular everyday Falcon 9, they were able to launch all of those spacecraft off of one launch instead of requiring the multiple they'd
yes, yeah.
anticipated.
The one
And
Falcon was able to hit all those different trajectories.
and it was crazy what was going on. They went up to 300 miles up, did a maneuver, released the two Grace spacecraft that work together to map out the Earth's gravity. Then they went to 500 miles up and just basically flung out Iridium satellites.
Yeah,
Goodbye, Iridium satellites.
yeah.
And this is a new era. And
I don't
the
know if that's
question
ever
is,
been done in that way before.
I don't know. So I
Yeah,
just flat out don't know.
yeah,
But we are in a new era of kind of launching all the time from all over the place, where you have rockets getting prepped at Cape Canaveral, rockets getting prepped at Vandenberg. And it's kind of
yeah.
awesome, but
It is kind of
it's,
surprising how much is just going on right now. The launch cadence is
yes,
legitimately so much faster. And again, we haven't even seen Blue Origin come into the race yet
right.
with any of their spacecraft as well. So apart from the from the suborbital hops that they've been doing. So and in theory all this uh, competition is going to drive down the costs of launches, which is going to open up entirely new kinds of launch opportunities. They're going to launch things that never seemed like it was a good idea to launch in the past. So this is, I mean, just overall, it's such an exciting time to be a part of this. And I feel like finally we're getting that science fiction future that we had always hoped for.
But at the same time, there's part of it that kind of looks like we're watching the folks in the back room who are building the old blue IBM mainframe, trying to keep up with the new kids who are building personal computers in their garages.
Yes. And I mean you're seeing some interesting responses, but I know like the head of Arianespace, you know, was not pleased at what SpaceX is doing to the launch market. And
Right.
you're seeing a response from United Launch Alliance with their Vulcan rocket. So they're coming up with their own version of reusability using Blue Origin engines and
Yeah.
reusable uh, parts to the rocket, but not necessarily the whole fuel tank. So there's different ideas that are coming in. It's great to see all of these, through competition and a genuine change. I mean, we saw the Block 5 from SpaceX launch just a week and a half ago. Well, it was like a week today, actually.
Yeah.
And it is the most reusable version of the Falcon that they've ever done. It's got the titanium grid fins don't need to be replaced. It's got all of this ablative material at all the places that get heated up. The whole thing is designed ideally to launch, land, be returned to the launch pad, stacked up again, and launched again hundreds, 10
It's
times before it gets maintenance, and up to 100 times plus per rocket.
and it's what we dreamed of with the shuttle, and we failed with the shuttle. Musk figured it out. It took an added 30 years,
Yeah.
but we're there. And it's just amazing to watch what is becoming possible.
Let's go with another question here.
And I'm going to look up when the next Falcon Heavy launch is.
July? Infinity Drew asks, why do some people suggest that life here on Earth came from Mars?
So it's just an idea. That doesn't mean it's a right idea. It doesn't mean it's a wrong idea. The idea is We know that we have rocks on Earth that originated on Mars because there were massive asteroid impacts on Mars. These impacts dug up bedrock and other rocks from Mars, flew them up at escape velocities through various orbital interactions. They made their way to Earth, flew down through our atmosphere, landed somewhere. Someone picked them up, looked at their chemical composition, and said, why, yes, this is a rock from Mars. And we also know that there are extremophiles like tardigrades that you put them on the outside of spacecraft, launch the spacecraft, have the spacecraft return to Earth, and the tardigrades are happy to come back to life. This combination of observables that there's life that can survive the launch and landing process, and there are rocks that got launched from Mars and landed on Earth, means that the theory of panspermia, the idea that life here may have originated elsewhere, or life here could have gone on to originate life elsewhere, is a potentially workable theory. Now, until we find life on Mars, whether it be fossilized, desiccated, still living, whatever state it may be in, we have no way of knowing if any life forms that exist on Mars are made of the same DNA and RNA building blocks, if they are made with even the same like orientation of their chemical bonds, the same chirility. Without understanding that, it's only a theory. So it's fun to think about what could be. And it's important to remember that we're only talking about what could be, not what is for certain.
Right. And the idea of it coming from Mars is just that Mars has a lower surface gravity than Earth does. So it makes more sense that material would be able to make the journey from Mars to Earth much more easily than material making the journey from Earth to Mars.
And Mars did have massive oceans early in its life and massive heavy bombardments of space rocks early in its life.
Right. Like all the planets.
Yeah.
Um, we've got just a couple minutes left, but let's hit some more. Steve Chisnell's asking, when's the orbital science Pegasus launch slated for? Well, the Pegasus launches, those happen all the time. I don't know when the next one exactly is. For people who don't know, the Pegasus is or the orbital science, it's like a Hercules, I think, or a 747. Anyway, it's a big airplane, and it holds a rocket under one of its wings, and it flies up to high speed, and then the rocket detaches and flies up and completes the launch. And the cool thing about the Pegasus, with all these air launch concepts, is that your first stage of your rocket is an airplane that can then land again and pick up another cargo and launch another one.
It's the Virgin Galactic model.
Yeah, but the sort of the next version of this is called the Strato Launcher, and this is a company that's being developed by Paul Allen, and it's going to be it's going to be the biggest airplane in the world. It's going to be sort of the next version of the Spruce Goose. It's got these two airplanes side by side with this big wing in between, and it's going to hold a rocket in between these essentially two airplanes bolted together, and then fly up to altitude, launch this rocket, land again, and send off another one. And it's an amazing concept. And I think up until what the BFR, what's happening with SpaceX, it made a ton of sense. Mm-hmm. But now, when you're looking at what the BFR is going to be capable of, that it's fully reusable in theory. Yeah. It's going to launch, land again, the parts will be reused, and away you go. So I think I did the math, and if the BFR hits the level, the price that they're thinking, it'll be cheaper than a space elevator.
So it'll be interesting to see which one has less vibrations on takeoff. Because I can imagine that if you're launching off of an airplane, that you have fewer vibrations than a rocket that takes off from the pad and then has to undergo all of the vibrations of trying to get up to speed. That's the only difference I can see that would be a reason But seriously, if you're building a rocket, it needs to be able to survive vibrations. So,
Hmm. Well, let's wrap things up. Before we wrap things up completely, I just want to make a couple of announcements. One, a big thanks to our good friends at the WSH crew. They
yes.
are, of course, the producers, the fans of the show. They hang out with each other over the summer while we're on hiatus, which is coming up soon. We're only got about
Yes.
another month to go before we're on hiatus. So definitely join that community if you want. Go to wshcrew.space. We we have to get Nightbot working on the Astronomy Cast chat,
Yes. Yes,
which
we do.
Nancy got it all going over on my own YouTube chat, but I've got to figure that out.
Okay.
But also on Monday, I'm going to be doing a live chat on my YouTube channel, and my guest is going to be Eric Berger, who is a aerospace journalist for Ars Technica, and in my opinion, one of the best space journalists that is out there. I'm a
Yeah,
gigantic fan of Eric Berger's work. He
I am too.
outscoops us all the time, and he is now releasing a new newsletter about the space industry, and so I'm sure we're going to want to talk about that. So that's going to be on Monday afternoon at 5 p.m. Pacific time. So if you want to do that, go and join my personal channel, my personal YouTube channel, and join us on Monday. All right.
And at
Oh, go ahead.
And I was just going to say, we are doing more and more streaming over on Twitch with CosmoQuest X. So tune in. I'm doing a quick roundup of the news Monday through Friday.
There's my Twitch
Uh,
shirt.
just 15 minutes long, nothing as in depth as what you get over at Universe Today, but it's that quick highlights and a chance to ask all your questions. And then I'm also doing things at the intersection of art and science on my personal Twitch channel, which is Star Strider with a Y. So we've got you covered for
Got you covered.
entertainment.
Yep.
Follow our YouTubes, follow our Twitches. We're not quite 24/7, but we're clearly working towards it.
Getting pretty close. All right. Well, thanks, Pamela. Thanks, everyone, for watching. We'll see you all next week.
Bye bye, everyone.